work with matrices. In other words, how to see if they're equal by looking at corresponding entries. We even talked about their little positions and how to label their little positions based on, you know, what column and row they're in. We even looked at solving an equation that involves matrices. Well, what we're doing today is we're going to talk about how to add and subtract matrices, and then we're going to talk about scalar multiplication. So help me God, why do people make my life so complicated? Why are... Okay, all right. Anyway, if I want to add matrices together, so this is matrix addition and subtraction. Those are opposite operations. For you to be able to add and subtract matrices, you have to have the same order in each of those matrices. Why? Because we add corresponding entries. So if an entry doesn't exist in one of the matrices, what are you adding or subtracting, right? So first thing you're going to want to do is you're going to want to look at each of the matrices and you're going to want to figure out what is the order. So what is the order for W?
2 by 2.
2 by 2. What about X?
2 by 2.
What about Y?
2 by 2.
2 by 2 and Z?
2
2 by 3. So if I ask you to perform each of these operations if they are valid, then you would say, all right, I want to add W and Y. So W is 3, negative 2, 1, 0. Y is 1, 4, negative 2, 3. So if I wanted those to add those together, what is going to be the order of the sum of those two? It is also going to be a 2 by 2. And to do that, well, okay, corresponding entries, add them. What do I get?
4, 2, 1, negative 1, 3.
Okay, 4, 2, negative 1, and 3. Easy. The biggest mistake people make is they don't realize what operation is happening here. They somehow turn this into subtraction or multiplication, which is a whole other beast that we'll talk about on Monday. So the next one is X minus Z. So if I want to take matrix X, 4, 7, 2, 5, 1, negative 1, and I want to subtract Z from it, 2, negative 2, 3, 1, 0, 4, is it possible?
Yes.
Yes, and the order of the difference is going to be what?
2 by 3.
2 by 3. So let's go ahead and look at corresponding entries and subtract. 1, 1 position.
2.
Keep going.
9.
Keep going.
1, 1.
What?
Negative 1.
Yes.
4, 1, 5. Negative 5.
Yes. So that's subtracting. Again, they have to be the same order for me to perform this operation. Now in the next one, you're being asked to add X plus, Y. If I look at X, 4, 7, 2, 5, 1, negative 1, and Y is 1, 4, negative 2, 3. You see this on the quiz next week, what happens?
No.
You say, I cannot perform addition. You have to explain. Because matrices have different orders. So there's a different rule for multiplying matrices. So if that is not satisfied, for that condition, you'd have to say, I can't multiply because of a totally different reason. So you do have to say that you can't perform the operation because of whatever reason it is. The next one is Z minus Y. So I have Z, 2, negative 2, 3, 1, 0, 4. And I want to subtract Y from it. 1, 4, negative 2, 3. What would you say?
I cannot perform subtraction and matrices.
Beautiful. Absolutely beautiful. Can't perform subtraction because matrices have different orders. All right, that's matrix addition and subtraction. The next operation I would like to look at and discuss is what is known as matrix scalar multiplication. So you're multiplying a matrix by a scalar. What is a scalar? It's just a real number. It's a fancy word for real number. So for you to be able to perform matrix scalar multiplication, well, all you need is a matrix and a scalar, and you can always do it.
Wow.
Because what do? You take that scalar and you multiply it by every single little term in the matrix. So if I have P, that is order. What is
3
the
by
order?
2.
3 by 2. Good. Q.
2 by 3.
2 by 3. And R.
3 by 2.
3 by 2. So you are being asked to not only perform scalar multiplication 3 times P, but then we need to subtract Q. So that's 3 times P minus matrix Q. So while you would be able to perform the scalar multiplication, as soon as you get to this point where you are to subtract Q, what would you notice? I can't. So what can't you do? You can't perform the subtraction, because you could do the scalar multiplication, but you can't perform subtraction because the matrices have different orders. All right, in the next example, you are to take 3 times the matrix R and subtract the matrix P. So let's do our scalar multiplication first. And then we will subtract P from that. Okay, so if I do 3 times R, what is the product?
3, 12, -6, 9, 0.
Beautiful. And can I subtract P from that?
Yes.
You bet, they're the same order. So if I perform the subtraction, what is the difference?
0, 14, -7, 9, -2, 13.
Fantastic. Magnificent. There you go. Scalar multiplication. Easy. Now, what happens if I give you an equation that involves matrices? Perhaps I give you some of the matrices, but then I ask you to find the missing matrix. Well, I'm going to take this equation. I'm going to substitute in for A. And I'm going to substitute in for B. Where people make mistakes is they put the wrong matrix in the wrong place. They somehow put the B here. I don't know how it happens. But it happens. Now, if this were a regular equation and these weren't matrices, and I'm trying to isolate the x, what would be the first step? Subtract this matrix A, right, from both sides. So let's do that. Can I?
Yes.
Yeah, they're the same order. So that's going to give me 4x equals what?
-8, -6, -3, -2.
Beautiful. So far, so good?
No.
Now.
I'm just like slow.
How are we dividing?
Okay, so to the next point, I'm still trying to solve for x, right? The 4 is standing in the way. How am I going to get rid of that 4? I love it. You multiply by the reciprocal. And then it's just scalar multiplication on the right-hand side. Right? So if I multiply this side by 1/4, that leaves me the x. I multiply 1/4 on this side, and this is going to give me x equals, take each of these, divide it by 4. What am I going to get?
-2.
Negative what? Yes. I didn't hear your 3 or 4.
-1/2.
Yes, and I'm done. Now, I could also substitute this back in, multiply by 4, add A, and see if it equals B, right? I can still check it. Okay, what about the next one? I have -2x minus A equals B. I don't know x, I'm solving for it, but I sure do know A, and I know B.
Should we go ahead and multiply by the scalar -1 just to get it over with?
Multiply by the scalar -1.
Can you scoot up like
I don't know how to say that. If we're subtracting A, I guess we just add it.
We good?
So do you treat the matrices as if it's just a
Disregard.
variable?
Yes and no. I mean, you're still moving it to the other side by performing the opposite operation.
Okay.
But once you move it to add or subtract its corresponding entries.
And then if matrix A was like 3, 2, what would that
And
just not
and B
happen?
wasn't?
Yeah.
Well, then you couldn't go any further.
So you would just
Yeah, there's nothing you can do because there is no matrix X that will ever
So-
work.
would you just put like write it out and then that would be your answer, or would you? Just
I'm
say,
never
okay.
going to give you one like that.
Okay.
All right, so how am I solving for X? First step, add
Add
matrix A to both sides. Don't be afraid of those fractions. They're all right.
I don't like them.
Get used to them.
Really don't like them.
You don't have a choice. Right hand side, what is the new matrix once I add B and A?
7, 3, 3 over 2.
7.
9. I'm sorry.
Ooh, it's not even a fraction.
Friday. I'm not gonna have. Alright.
Yeah, didn't even have to get a common denominator.
Excuse me.
Okay, I'm solving for X. What would be the next step? That's right. Multiply by the reciprocal, which is -1/2. Now that is dividing by -2. However, I really don't want you to think about division when we're working with matrices because you can't divide matrices. So division really is kind of, it's multiplying by the inverse is what you want to do. Okay, so that's going to leave me X. And then if I do scalar multiplication, what am I going to have?
3.5.
5 over 2, -3 over 2,
Beautiful. And you're done. Now, I am going to save matrix multiplication. So we'll skip that page, we skip this page, we go here. I'm going to skip that because Monday is all about matrix multiplication. So I want you to have a nice long weekend, restful, doing math, of course. Making sure you become one with everything we've done so far in matrices so that when we get to the matrix multiplication, you are ready. It is cumbersome, but it's joyful. All right. Now, since we just talked about addition, I do want to point out 2 things that you should know with respect to addition and matrices. The first property, which we have discussed with respect to real numbers, also works with matrices. The additive identity. Well, if you have a matrix A, not a real number, not a scalar, but a matrix A, if I add the corresponding size 0 matrix to it, I mean, it has to be the same order, right? If I add a 0 matrix to A, I get A back. So what is the additive identity for matrices? It's a 0 matrix of appropriate order, right? So the additive identity is the 0 matrix. You need to know that. That is in contrast to the additive inverse. If you think back to real numbers, if I gave you a real number and I asked you for the additive inverse, it was the opposite. The number's the same direction, but in the opposite direction of 0 on the number line. So, you are asking yourself, what am I adding to this matrix to get 0? The opposite of the matrix. So the additive inverse is the opposite of the matrix. You're just changing the signs of every single element in the matrix. So if I give you this matrix and I say, hey, what is the additive inverse of A? All you're doing is giving me the opposite of A, which would be?
-1, -2, -3.
Exactly. So you better believe on that quiz, you're going to need to know what the additive inverse and the additive identity are. Don't get them confused. So when is your quiz?
Next Friday.
No.
Did you move it to next
I
Thursday?
did.
Okay,
Thank
that's nice.
you.
Okay, so your quiz is now Thursday because Friday shorter classes and God, we need all the time we can get
And
to
I'm
do
not
these
gonna
these
be.
quizzes.
Yes, these are
okay?
very.
Now, with that being said, the non-calculator part is Thursday. There is one calculator problem. You can guess what it is. I'm not going to say it, but you should be able to guess. What's the only thing we've done? Calculator. That will be on Wednesday, the very end of Wednesday, and there will be a bonus on Wednesday. And you could probably guess what that is too. All right? So the actual quiz is Thursday for the non-calculator part. Wednesday at the end of block, we're going to have The calculator part, one problem and a bonus. Yes, ma'am?
Can we use the calculator on the bonus?
No.
She said yesterday the bonus would just be a very long calculator problem without a calculator.
I mean, yeah, exactly. All right, so if you want additional practice on the basic matrix operations, adding, subtracting, scalar multiplication, take one, pass it around, it's yours. Now, my question to you is, if you're at home doing these this weekend and you wonder if they're right, is there a way for the calculator to tell you the correct answer?
I hope so.
Of course, let me show you how to do these basic operations on the calculator. Yay, Cameron! Okay, you need your calculator. All right, so hopefully you remember from yesterday, or the day before, or whenever it is that we did it together, how to enter a matrix in the calculator.
Second matrix.
Second matrix, and then I'm gonna edit, right? And I'm gonna put in my matrices.
And then
Now,
math.
The order of matrices.
right, and then RREF if I wanted to calculate the solution. Can't see this.
It's just need to turn off the light. Or you can
Oh,
do
that's
that.
perfect.
Okay. All right. Which of these matrices could I add together?
3
A and B or
C and E, right? They have to be the same order.
Yeah.
So let's say I go ahead and say, all right, take matrix A. Oh, no, wait, sorry. Okay, take matrix A. I want to add matrix B to it. You said I could do it. Yes, I can. Right there it is.
We cannot see.
Oh, that's so cool.
Still no.
I'm trying. Give me a moment.
There we go.
Right.
Sorry.
It's not focused. You see it?
Uh-huh.
Subtraction, same thing.
Oh, sure.
What is scalar multiplication? 3 times a matrix. There it is.
Wow.
Okay, so it's going to perform those operations for you, so you
That
can
is
check
so
these.
legit.
Now, thank you. What happens if I try to add matrix A
And C.
and
Error.